But I want to, and I don't want you to freak out that it says the word proof. It's not that there is no, guys, you don't have to worry about the fact that it says proof here. It's not that we're doing actual proofs. What we're doing is that we're going to use the idea of how we can show that things are similar by knowing a couple of rules, okay? Because just like when we talked about congruency, when we talked about all the different types of congruency with triangles, remember the very first thing we talked about was that if things were going to be congruent, then they had to have all corresponding parts had to be congruent, which means you had to have 3 angles and 3 sides. After we did that for a little bit of time of working with that, we started to whittle away at the idea that you didn't have to show everything. We had to show some of that alphabet soup. This is kind of the same idea, that you don't have to show that everything, all the angles are congruent and all the sides are proportional to be able to say that they are similar. What we're going to be able to do is just show it by a couple of parts. Well, the first thing that we show it is by what's called angle-angle, okay? Angle-angle similarity is just that. If you have 2 angles that are congruent in a triangle, the triangles are similar. That's it.
Wait, what?
If 2 corresponding angles congruent between 2 triangles, then triangles are similar.
Okay.
That's it. And then you could write out a similarity statement between the 2 triangles, like you did yesterday, and you listed out all your parts and your side lengths, altitudes, all of that. But it's a matter of being able to show that you have 2 angles that are congruent. If you have 2 angles that are congruent, don't the third angles have to be congruent?
No. Yes.
Think about it.
Yes.
If you have an angle that's 30, the other angle's 60, and then one triangle, one angle is 30, the other one's 60,
Yes.
you have to have, the other ones have to be 90. But it chooses because it has to.
He doesn't have a choice. It's his lifestyle.
Stop. Just stop.
So, guys, so basically what happens here is that if you're able to show that you've got only 2 pairs of angles that are congruent, that means triangles are going to be similar. And you have to be able to write out the statement, following tick marks and going through like that. And then you can get your scale factor and do everything else, like we've been doing the past couple of days. Excuse me. Let me show you an example. So here are 2 triangles. Yes, ma'am.
Is it okay if I like flip that other triangle as long as I just keep?
As long as you, I would draw it how it is so you get accustomed to how things look, because it doesn't matter how the triangle is manipulated, letters. So I want you to try that, okay? So let's draw out these 2 triangles and see what we can figure out as far as the missing angles, and write out a similarity statement if possible, okay?
Yeah, we know you.
Yeah, this is great. I like stuff to simple things. So, what does that little box mean in a triangle?
Right angle.
Hey, right angle. Hey, but if we have the right angle on 2 different triangles, aren't they going to be congruent, those 2 angles? Yeah. So we have to figure out what the measure of angle K is and what the measure of angle E is. So, guys, come on. How many degrees are in a triangle? 180. Take out the 90, what's left?
64.
90. Subtract 64 from 90, what do you get? Subtract 26 from 90, what do you get? Are these 2 triangles therefore going to be similar?
64, not
Yes.
54.
That is a 6, the light,
It's
the,
a 5 line.
okay. I don't need any comeback stuff here, okay? Sometimes when the marker draws stuff out, people might not recognize it, all right? Now it's just a matter of picking a spot with the lettering to label the triangles. I'm reading from left to right, so I'm going to say triangle CDE is similar. Well, what does the lettering have to do to match it up?
K,
Yep.
G, H, H.
And now you can do everything that you've done the past few days. What this is asking, just like we did earlier, we started this whole unit by cross multiply, solve for x. After that, you were given letters. You had to substitute in, cross multiply, solve for x. After that, you were given a similarity statement. You substituted in letters, and you substituted for x. Then you cross multiply and solve. Here, you are going to give angle measures. Then you have to come up with a statement. Then you have values, and you can cross multiply and solve. Guys, each and every one of these steps, or every one of these sections, builds off of what you've done before. So once we do this, everything else is exactly the same, okay? It's just a matter of being able to tell whether or not you can come up with it.
You just put like the angles.
Yeah, label them out. This is where, and this is another style of problem then. A flagpole casts a shadow that is 50 feet long. At the same time, a woman standing nearby who is 5'4" casts a shadow that is 40 inches long. How tall is the flagpole to the nearest foot?
Draw a picture.
And this is where you have to be able to draw a picture of what something looks like. Okay? Okay. Now, what's happening here, guys, what's happening here is it's going to take into account a couple of properties that you guys have yet to learn about. Okay. Now, when you have a shadow, what generally has to be up in the sky? The sun is usually a helpful thing to have in the sky.
Got it.
I never realized the sun has a smiley face.
Dude, see Kelly Club's still getting freaked out.
So there's the sun.
Sunshine.
Yes, sir.
Like, is there really any difference between saying like a sun and
Huh.
sun?
I'm gonna name it Sunshine.
Not really. Depends on what system you're. If you're in like certain solar systems that might have multiple suns. So you have a flagpole. Well, obviously we have the ground. You have the flagpole. And then you have the person.
It looks
Let's
like
draw wood. Just let him.
Well, it's a girl. So she's got one.
it looks like a golf flag.
So now here's what happens. Under an assumption that what they're going to give you guys for this, we know that the flagpole was how tall? It was 50 feet tall. And the girl was 5'4". Okay. Now, what I want you guys to think about is that the sun casts what we call a sun's ray. You okay with that? It's a drop of molten sun.
Or sunshine.
And it comes down like this. You okay with that?
Yeah.
Okay. Now, here's what happens. When you're measuring something that's on the ground to its vertical height, it's always assuming that this is going to be a right angle at the base. Okay? Those are both right angles. Now, when two things are perpendicular and they intersect the same transversal, if you will, that means that these two, since these two have to be parallel to one another, be okay with that? Which means that these angles here would have to be congruent because they are corresponding. Right? They're on the same side of the transversal, on the same position. Right? These are equals. So that means that they are sharing. They have both angles, that angle-angle similarity, if you will. Okay? Or another way you can look at it is, there's two triangles here. There is a large triangle going up to the flagpole, and there's a shorter triangle to the girl, which means they have a shared angle here as well. It doesn't happen very often that we have seen in the past that reflexive angle. Sometimes it shows up within similarity, but now this is why this is going to work. They have two triangles, a small one and a large one, shared angle here to the ground. Angles at the heights of the two objects are also the same. So we have this angle-angle similarity, which means we need to figure out, I'm sorry, the flagpole was not 50 feet tall. The flagpole's shadow was 50 feet. I apologize, I said the wrong thing. Flagpole's shadow was 50 feet, and the girl was 5'4", and she had a shadow of 40 inches. And the 50 was the whole side here. Bless you. Okay. So now, what we need to do is figure out how to set up the ratios. Now, very simple. We can just go height to shadow or shadow to height. It doesn't matter as long as you are consistent. So if we say height to shadow, we have a 5'4" to a shadow of 40 inches. You guys know what those tick marks mean? We're okay with feet and inches. To some unknown height to a 50-foot shadow. Which means we have to do what to make this work?
Cross multiply.
What do you have to do first? Convert, very good. You have to convert. You gotta be in the same units to make this work. Now, is it easier to work in the upper unit or a lower unit? Lower. We need to convert everything into inches, okay? So, how many inches are in a foot?
12.
Good. So we have 5'4", so that's 5 times 12 is 60 plus 4 is 64. So that means we have, all right, hold on. We have 64 over 40 is something over, what's 50 times 12?
600.
600. And now we cross multiply and solve.
And is there a fraction that you can reduce there?
You can, but if we have our calculator, it's not a big deal.
It's not a big deal.
All right.
Yeah, so
To make things simpler, if you divide 64 by 40, you get 1.6.
well, you don't even bother with it. Just cross multiply and solve. Because you still have to do work with the fraction. That's when you do all the other stuff here. Just cross multiply and divide out. What do you guys get in terms? Now remember, your answer right now will be in terms of inches. What do you get?
909.
You get 9,600 inches is the height. And now it asked us for the problem. What's wrong, Hannah?
I got
Yeah, I got 960. Is that 6?
960 inches.
960?
Yeah.
Did you make too many? You have an extra zero? So that's how many inches it is?
8.
Which means we have to divide it then by
12.
divide it by 12.
You get 80.
Gives you how many?
80.
80. So it's 80 feet tall. You will, but what I'm saying is you gotta be careful when you're dividing or multiplying by the 600, and that's what I'm getting. Okay. And that's how that works. It's the idea that, as complicated as this might get, is the fact of trying to set up, excuse me, trying to set up to make sure that it can cross multiply itself out. Okay? Get much further than that.
This will work.
Hold on a second, Austin.
You socks are crazier.
You know, let's see. Yeah, I don't know if we'll have.
You don't know if we'll have them.
No, I know we'll have homework. I'm just trying to see.
I was getting ready to get excited. gonna be 9.
I'm trying to think if there's anything else here.
Everyone gave us 2 problems.
Yeah, you know what? Let's just call it on that one because that would give you guys. I think we're okay because the last of it is kind of the exact same, but we can finish that out tomorrow and build it into the next thing. Excuse me. Nothing really. Well, then it goes. Same stuff. Sorry, I can build that into here. This is the last one. So. All right, let's do these then.
Hey, Mr. Murphy, is it to finish rest of the lesson?
What?
Is it our homework to finish the rest of the lesson?
No. Let's do this. Let's do 3 through 14. And
That's 11, 12, and 13.
let's do that. Those work.
That's not bad.
That's 11, 12.
Chapter 6,
Yeah, this is 6.4.